start module 13, looking at another kind of test where now we're going to look at categorical variables, and we're going to do that in two different ways, either the chi-square goodness of fit test or the chi-square test for independence. And here again, the difference between these and the other ones is that we're going to focus on categorical variables. And as we do that, this term chi, you can see how we spell it, chi-squared, is a test statistic that gets calculated, which we will not do by hand. So there's a one page here kind of explaining the mathematics behind it. It's a distribution where we're comparing expected values with observed values, right? How often a categorical variable is occurring, right? The percentages. So we have expectations, right? We've used that term before, and then we actually observe something, and then we check to see if we see something different, right? So we'll talk more about that, and then look at that as a with contingency tables. We have two categorical variables. So there's a little story here about the chi-squared distribution. Again, this is more the mathematics behind it, but a chi-squared value, you can see this notation right here. It's chi squared. Again, you see something, it's always going to be a positive value, always greater than 0. The distribution depends upon the number of categories the variable has. So again, this is a generic look. And then we'll calculate the probability once whatever the value is. It again is determining the farther away we are, right? And it gives us a p-value from our expected value. Then we'll make some decisions. Sometimes some classes do calculation by hand. It just takes a long time, easy to make mistakes. It's like a Z and a T. You can do some calculations, right? But we'll use the art of stat in our class. And the art of stat helps us get those values for us, and we can pick those off. You're going to hear this term degrees of freedom. This degrees of freedom, again, it's related to the number of categories, and that's what kind of determines the distribution, the shape of the distribution. But again, you're not going to worry about that much. And so what answer, right, does a chi-squared test give us as we analyze some data? So we start off with a graph here, and so it starts off with according to census data. So this is information based on 2019 census, the distribution of race, okay? And then we compared that distribution with the distribution of professors, lecturers, or instructors in colleges. And we have certain values, the numbers. We could have the percentages or the values. You can see both here. And so the question of interest is, do we think the distribution of professors, the demographics, matches the US Census? Whether we agree it should or shouldn't, that's a different question. The question now is, does the distribution match up, or do we see a difference? For example, this number here is 75%. There's 60% white in the population, 75 as professors. So is that large enough? Is that far enough away for us to say there is something different, something's going on? And this would be a chi-test goodness of fit. That's what we would. And then we check all of them. See, it's hard to compare them all. The 11% is Asian, only 5.9%. So our instincts are kind of saying that this doesn't match up to the distribution, right? What we observe here, right? Observe here. Does it match up with what we expect to US Census? And so that's the question that we would be trying to answer.